So this is a session on principles and practice for merger review. We've got three very interesting papers that are about the process of merger review. We're running a tiny bit late, so I will barely say anything other than to first introduce the first speaker, Yossi Spiegel, who is professor at the Tel Aviv University and president of the Israeli Economic Association, and actually was my colleague. He isn't in his bio, but he was my colleague on the EAGCP at the chief economist team in Brussels for a while as well. Yossi.
So thank you, and I'm happy to be here. This is a short paper that deals with the standard of proof in merger review. So the background is that in many jurisdictions, including the US, the EU, the UK, the standard of proof in merger control is the balance of probabilities, where the question is the merger more likely than not to substantially lessen competition? But recently, some people started to argue that this is not a good standard, because we don't care only about the probability of harm, we also care about the size of the harm. And if there is, say, a 70% chance that the merger will yield good outcomes, but there is 30% chance that it will be catastrophic, then we should give more weight to the negative outcomes. And the balance of probabilities just doesn't take it into account, and the merger will be approved, which doesn't make any sense. So, for instance, the Foreman report says the balance of harms standard would provide a strong, clear, rational, economically sound approach to appraising mergers. And then in merger cases involving potential competition and harm to innovation, a balance of harms standard would only broaden the set of mergers which may be found problematic. And Mota and Peitz in a recent paper argue similarly. They say the relevant criterion should be that of expected gains in consumer welfare from competition are larger than the gains that would come from upgraded offer of the merging firms. Such a balance of harm approach has been proposed by the Foreman report, and we fully agree with it. And Luis Cabral has an interesting paper where he runs some calibration exercise, and he shows that a move from balance of probabilities to a balance of harm standard is going to raise welfare substantially by blocking bad mergers. So when I read all of that, I just got curious, because these arguments sound very intuitive, but the question is, what are the set of circumstances under which the intuition is correct, or maybe the intuition might be misleading? And clearly we need to know better the trade-off between the two standards. So to clarify, I wrote a little model. Actually, it's not a model, just formalizing the ideas. There is nothing to it. So consider a merger, and suppose that the merger, if approved, leads to some outcome Y. And the outcome Y could be whatever you are interested in. For instance, could be consumer surplus, or if you're interested in total welfare, or if you're interested in a mixture of the two. Okay, the outcome is Y. And suppose that if there is no merger, then the outcome is C. So let X be the difference between the outcome with the merger and the outcome without it. So X is the welfare effect of the merger. And let's suppose that X is distributed on some interval, which includes both negative and positive outcomes. So the merger could have a positive effect, could have a negative effect. And the reason why you don't know what the effect is that you always approve mergers, or you need to block mergers before you know what the realization is. And you always do it with some uncertainty, because you don't know whether there are actually synergies involved. Firms promise the synergies, but you don't know whether they tell you the right story or not. And even if they tell you the right story, you don't know whether it's going to materialize or not. And of course, you don't know if, say, the merger doesn't go through. It could be that the target firm, and this is especially in the digital world, where some big tech giants acquire new startups. You don't know whether the startup is going to develop into a huge and successful company, or maybe it won't. So there is this uncertainty, and the uncertainty is X. So under a balance of probabilities, you just want to find out whether the probability of the outcome being negative is below 50%. And if that's the case, you allow the merger to go through. But if you think about it, this is exactly the median. So basically, you want to know whether the median outcome is positive or negative. If the median outcome is negative, then you just block the merger. If the median outcome is positive, you allow the merger to go through. So under a balance of harms, you don't look at the probabilities. You look at the outcome times the probability, and obviously you integrate over all possibilities. So basically, you get the expected outcome. And if the expected outcome is negative, you block the merger. If the expected outcome is positive, you allow the merger to go through. So now when you compare the two standards, you see that actually the difference between them is really much more subtle than you think. And why? So the people who argue that the balance of probabilities is incorrect or misleading, or we should deviate away from it, emphasize the fact that you take into account only the probabilities, but you don't take into account the outcomes, which is formally correct. But then, if you think about it, both standards look at the entire distribution of possible outcomes. And as usual, we summarize the entire probability with just one summary statistic. And that's the number that we look at. So the two standards take into account the distribution, but they focus on different summary statistics. The balance of probabilities focuses on the median. The balance of harms focuses on the mean. And now when you say that, it doesn't jump on you that one is inherently better than the other. And, at least in my view, it shifts the debate from saying, this takes into account the outcome, doesn't take into. It's just, different summary statistics. And, you can love the median or you can be in love with the mean, but, that's a debate. So now, many people have argued that, okay, so in recent years, obviously, merger control is under a lot of criticism, and many people, blame lots of the harms in the world on antitrust authorities that presumably are not doing their job, and they are too lax. And therefore, we have this and that and the other. And some people even kind of suggest that part of the problem is that antitrust authorities focus on the wrong standard of proof, and this reliance on the wrong standard of proof, the balance of probabilities, is the reason why we have all of these bad mergers. And in particular, they say if only we shift from the balance of probabilities to a balance of harms, then antitrust authorities are going to be much tougher on mergers, and they are going to block many more mergers, and all the evils of the world are, no, okay, I'm exaggerating, but things are going to be much better. But if you think about it, the distribution of outcomes could have a situation where the median is above the mean. And I mean, okay, if you look at the distribution, the mean could be equal to the median, or could be above the median, or could be below it. So, for instance, you can have a situation where the median is positive and the mean is negative, and then if you adopt a balance of probabilities, a shift from one to the other doesn't have to necessarily broaden the set of mergers that are being blocked, because again, the balance of harms look at the mean, and if the mean is negative, you're going to block the merger. But the balance of probabilities look at the median, and if the median is positive, you're going to approve it. But it could be the other way around. So really, everything depends on the shape of the distribution. And I haven't seen any argument that says that most mergers have a mean above the median or vice versa. So the implication is that it's not clear which standard is better. But to clarify it a little bit more, I did the following. X, the outcome, is a welfare outcome. And the question is, why is welfare random in the first place? So welfare could be random in the first place because you have some random variable that you are not sure about. You can have even more complicated situations where the uncertainty is driven by several factors, which could be demand shocks, cost shocks, innovation, whatever. But let's make things simple and assume that the welfare outcome is uncertain because of some variable z, which is distributed somehow. And z could be, for instance, the size of the post-merger synergy. Or z could be the efficiency of the target firm absent the merger. So let W star z and W double star z be the objective function of the antitrust authority before and after the merger. So really the merger effect is delta WZ. And suppose that WZ is monotonic in Z, in the sense that higher values of Z are associated with better welfare outcomes. So the median of the welfare, given the distribution of Z, is just delta W evaluated at Z hat. And under a balance of probabilities, the merger is blocked if W of Z hat is negative. Again, the Z is distributed, and you take the median value of Z, and because W is monotonic, the median of W is the same as the, is when you take Z equal to the median value of Z. And the mean of delta WZ, the mean of the welfare outcome is just the expected value of delta WZ. And under a balance of harms, merger is rejected if the expected value is negative. So now you can apply Jensen's inequality, and you can compare the median value of delta WZ to the expected value of delta WZ. And as we know, if delta WZ is strictly convex in Z, then the median is below the mean, and conversely, if delta WZ is strictly concave. So the implication is that actually everything depends on how the welfare effect looks like when you plot it as a function of the underlying variable that generates the uncertainty. And delta, the welfare effect could be concave or convex. And if it's one, then the median is above the mean. And if it's the other, then it's the other way around. So actually, if you want to justify one standard over the other, you should say, I think that most mergers are such that the welfare effect is a convex or concave function of the underlying variable that generates the uncertainty, except that I never heard this argument made before. So I think that maybe there is a contribution here in terms of this is what you need to think about. So at this point, it's a little bit too abstract. So I just took two examples to illustrate. And why did I choose two? Because I wanted one in which it's concave and the other one in which it's convex, just to show you that you can easily generate either. So there is no a priori sense in which it's always convex or always concave. So the first example, and both of the examples are just things you teach in class. It's very plain, but I think this is a strength because it means that you don't need to work very hard and you don't need to be very clever in order to generate examples where the shape is this or that. So take the most classic model of merger. There are at least n identical firms. They compete, they are Cournot competitors, they produce a homogeneous good. The inverse demand function is just linear. Suppose that the cost is linear as well. To those of you who are familiar, this is like the SSR model, Salan, Switzer, Reynolds, classic paper. So we know that in this model, no merger is ever going to be profitable unless it involves 80% of the firms involved. But of course, at that point, no antitrust authority will ever approve it. So I assume that there is a synergy if the merger goes through. And well, these are the expressions, without a merger. Just compute, it's a Cournot model, and then you have I assume that the welfare standard that the antitrust authority adopts is consumer welfare. And just this expression that we show in class, just simple Cournot. And if the two firms merge, suppose that the cost of the merged entity is reduced by S. So, previously the cost per unit was K. Now, after the merger, the cost per unit is K minus S, as is the size of the synergy. And then you can work everything through. I mean, again, it's like a little problem set for your undergraduate students, and you can compute consumer surplus, and it's this expression, doesn't really matter. And obviously, we know that without synergy, the merger is not profitable. Again, this is the classic SSR result, QJE 1983. So obviously, if the synergy is large enough, then you can overcome the SSR result. So I assume that the synergy is, well, the synergy is uncertain. You don't know what the synergy is. But if the synergy is always below the threshold that makes the merger profitable, then you should not see a merger be proposed. And obviously, if it is proposed anyway, it means that your model is wrong. So let me assume that the distribution of S starts maybe from 0, no synergy, but then it increases above the point where the merger is profitable. So you have a range of values for which it is profitable. And then we know that the merger is enhancing consumer surplus if the synergy is sufficiently large, so in particular above this threshold. And then you can have a range of values from low S to high S, again, the synergy. So if S is very low, the merger is just not profitable. If it's large but not very large, then it's profitable, but it harms consumers. And if it's very large, then it is both profitable and it helps consumers. So, this is, again, stuff that if you teach antitrust to undergrads, probably you show things like that. And then suppose that initially the antitrust authority believes that S is distributed uniformly over an interval that starts from very low value up to a very high value, so in particular covering all the 3 possibilities that I've seen before, I showed you before. And again, the uncertainty here is driven by the cost synergy, which the antitrust authority doesn't know. And then you can compute the mean and the median, and let's assume that S has a symmetric distribution such that the mean and the median of S are equal. This doesn't mean that the welfare, the welfare generated by different values of S is symmetric. It will not, in fact. It will have different mean and median, but still, the underlying variable itself, suppose it has the same mean and median. And then you can apply Jensen's inequality. Why? Because delta CS is a quadratic function, so it's a convex function. And if you have a convex function, then the welfare evaluated at the mean outcome is below the median outcome is below the mean, and therefore the merger is blocked under a balance of probabilities if it so happens that the median is negative and the mean is positive. So moving to balance of harms will only imply that you approve mergers that would be blocked under balance of probabilities. So, this goes against the hope of those who advocate a shift because they think you're going to be tougher. So, had I concluded here, you would say, okay, this is a bad idea to move to a balance of harms. But then I show here another example where it's the other way around. So here, in order to make sure that the two examples are as close to each other possibly, I assume the same setting as before against this plain model that you show in class. But I assume that without a merger, the cost of the target firm is going to be K minus R, and R is the extra efficiency of the target firm, which you don't really know before you approve the merger, because say you acquire a new firm and you don't know how efficient it's going to be. So, post-merger, I still assume cost synergy, because I need it, otherwise the merger will not be profitable. But now I assume that the cost synergy after the merger is known in advance. So the only uncertainty is about how efficient the target firm is going to be if it is not acquired. And you can solve everything and work it out. And now it turns out that delta CS is actually a concave function of R. before it was a convex function of S. Now it's concave function of R. So it's a concave function of the variable that generates the uncertainty. And because of my results before, then the median is above the mean. And if it so happens that the median is positive and the mean is negative, then shifting from balance of probabilities to balance of harm will induce you to block mergers that you would have approved otherwise. So just in conclusion, neither standard seems to be, to me at least, dominant and obviously better than the other. And the hope that somehow you're going to be tougher if you move from one to the other, is questionable. And really, it depends on the shape of the distribution of outcomes, which could be convex or concave with respect to the underlying variable that generates the uncertainty. And I showed an example where it's concave and another example where it's convex. And at this point, you can say, okay, the first example is about the cost synergy. The other one is about the efficiency of the target firm. So maybe there is something general here. But, I'm pretty sure that I can work examples where, it's one or the other and it's the other way around. I mean, just wrote a little model just to say that all of these things are possible. And my conclusion is that this is obviously an interesting discussion. We should continue. And this is just a little step further saying, you should be more careful and formalize your ideas. And, the jury is still out there, which is better.
Thank you very much. Okay, we have a little time for questions. I'll go for Franco first.
Thank you, Yossi. Very, very interesting. So the one aspect is the one thinking what's missing in the model is the deterrence effect. The deterrence effect will change the function itself. So this comparison is conditioning. There is no deterrence, but if there is deterrence, whether it is the mean or it is the median, you might have a different function than the one that you're looking at. And it's added complexity, of course, but merger is also one of the effects of the merger control is deterring mergers and producing a different, set of outcomes, distribution of outcomes that will come there. Yeah, thanks.
I totally agree. I mean, the model is the simplest model possible, and obviously, if the merging firms know that they go with the merger and the merger is blocked, maybe they will not pursue the entire thing. But then I would say, there must be some uncertainty about the antitrust authority judgment to make the model interesting, because typically you don't really know. Yeah, I mean, maybe there is another paper here, which is, it's always great.
Farasat.
Thank you. So I think what you've shown very clearly is that shifting the standard is basically switching from mean to the median. Doesn't it then imply that the next step should be looking at distribution of past cases on welfare and seeing whether they have a left skew or a right skew? Because whether it has left skew or right skew basically tells you how many more mergers are going to go, because that's what's going to give you your convexity or concavity condition.
I think that would be a great exercise, and I'm...
We don't need that. It's going to be right skewed. I don't think you can have any left skewed distribution with this type of...
But that's a prior belief.
Any other questions, Russell? Oh, lots of questions. Actually, I'll tell you what, we'll take a set of questions. So first of all, Russell.
But my problem is that once you take a set of questions, I don't remember any of them.
Well, just try and remember them and answer what you want.
Thank you. Very interesting. I take your point that neither strategy is implicitly tougher or easier on mergers. But I do wonder, just thinking about it, it seems like the second strategy, the balance of harms, it seems like this first strategy, the balance of probabilities, you're willfully ignoring some information you have. And if you have, even uncertainly, if you know that there is a really bad outcome that's possible or a really great efficiency that's possible, if you just do the balance of probability, you're just saying, no, don't tell me, I don't want to know that. Whereas with the balance of harms, you're taking account of all more information, or at least more prediction.
Here I must disagree, because in both cases you look at the entire distribution and then you summarize it with one number. One is the mean, another one is the median. Would you say that the mean has more information than the median? No, they are both summary statistics, and they ignore a lot of stuff because they summarize an entire distribution into one number.
The mean says more about what's going on away from the median.
Exactly, that's my point.
Just
yes.
a summary statistic. I mean, anyway, I mean, distribution is a whole distribution. When you summarize it with one number, you lose a lot of information anyway. So,
Sorry, I didn't go to the other questions first. Let's carry on very briefly. There's two questions, I think. And yeah.
Thank you. Hi, very interesting presentation. I was wondering, you just said that, so we're looking at summary statistics, basically median and mean, and this really reminds me to some kind of macro papers in which you have a threshold, and you have one world if you are above the threshold, and another very different world below the threshold. What you just said in this presentation is that if you have a world in which the probability of harm is 51%, then you block the merger, but if the probability of harm is 49%, then you don't block the merger and the merger goes on. Maybe the debate should be on whether we are using a good theory of harm in which, when we have a very narrow decision, we can end up in very different worlds, just slightly changing the probability. That's what I was thinking.
I guess your question is more like, what's the optimal rule here? And I agree with you. It's an open question in my mind, because I just took. Actually, people even debate about what is the actual meaning of the balance of probabilities and whether actually antitrust authority use it. So I took just a Mickey Mouse description of what antitrust authorities do. But the question, what's the optimal rule, is definitely no.
Because it feels like we have.
I'm going to actually have to close it down.
Sorry.
Maybe you could chat
Yeah,
with each
maybe.
other. So, and
Thank you.
I'm afraid I can't go to the last question, particularly as I want to just say a couple of things as well. One is on your point. What is true in the real world is there's also a substantiality. So both of these merger tests would have a kind of substantiality. It has to be more than it's not just if it's greater than 0, you block the merger. It's if it's greater than kind of 5% above 0. But I don't think actually that would change your overall analysis. So the other point, though, is just a very factual one. Having been part of the Furman Review, I went back and reviewed what we wrote, and we were rather blurry on the point. However, our recommendation wasn't to switch, but to increment the balance of probabilities with the balance of harm, so that you would actually have the ability to use either, whichever you thought was the more appropriate in the specific circumstances of a merger. So I think in that circumstance, it definitely would enable more mergers to be blocked. I think there's a different question on the basis of your analysis, whether that's a proposal or not a good proposal, but just kind of for factual accuracy in the face of rather blurred writing within our own report. So let me move on. Is it Kaustav? Yep. Okay, so Kaustav Das, who is from the University of Leicester, is going to be talking about innovation and mergers, which is a very hot topic at the moment. So great.
Okay, thank you so much for giving me this opportunity. So this is a joint work with Tatiana Mayaskaya from HSC Moscow and Arina Nikandrova from City University London, City St. George University London. So the starting point of this research came from the merger of Dow and DuPont, which was actually announced in December 2015. One of the things was that the European Commission was a bit skeptical about this merger, In fact, they raised a novel innovation-based theory of harm, and their concern was that this merger might cause a reduction in R&D investment. Finally, in 2017, when this merger was cleared by the European Commission, it was cleared on the condition of divestment of DuPont's global R&D organization. Now, what are the trade-offs in merger and innovation? One is the cannibalization effect, in the sense that innovation by one of the merging party, they think that it diverts sales from the other party, hence it leads to lower the R&D incentives. On the other hand, if we think of more than one innovations or more different stages of innovations, then it is also important that we have to take care the extent to which a firm can capture present and expected future benefits from an innovation it makes now, which we call the appropriability effect. And as I will show, that a merged entity might have a higher R&D incentives on that front. So what we do in this paper is that we build a dynamic model of R&D to take care of more than one innovation possible. And we ask the question that, do mergers reduce or increase the expected number of innovations? And also, do mergers bring forward any innovations in time or delay it? And if it does so, which kind of innovation it does so? To give you a preview of the results, we say that we show that in our model that the merger affects different types of innovations differently, in the sense that if we consider of two kinds of innovations, first is a game-changing innovation and then a follow-up innovation, then the merger might increase the probability of the game-changing innovation due to higher appropriability. On the other hand, it might decrease the probability of subsequent innovations to avoid cannibalization. Finally, because of the model, which I will explain shortly, we have shown a novel informational effect through which merger can bring the game-changing innovation forward in time. So finally, and the policy implications, we show that in the case when it is more uncertain about the feasibility of the game-changing innovation, merger might be better. On the other hand, when there is a greater certainty about the feasibility of the game-changing innovation, merger may not be that good. And contrary to our textbook thing, we show that at certain situations, it might be beneficial from the consumer's point of aggregate welfare point of view that merger is better when this subsequent innovations and the game-changing innovations are close substitutes. Rather, so the traditional textbook economics have always learned that merger is bad when we have substitutes. However, we show here that sometimes it might be better to have a merger situation. So in the rest of the presentation, I'm going to show how we achieve these results. So to give you a starting point of our model, we use the two-armed bandit model in this framework, in this paper. Now, just to give you an idea about two-armed bandit model, the name comes from the traditional slot machines, since that if a priori you don't know at what rate you're going to lose money or get money if you put some money in the slot machine and pull the arm. That's why the name bandit comes from the fact that the slot machine tends to take away money from your pocket. So that's the name bandit. However, to know that, first thing necessary is that you have to put some money, meaning you're not using that money for a different purpose, right? So you put more money, more you see how you are losing or getting money, you are learning about the nature of this arm of the bandit. So this kind of model actually can let you understand the classic trade-off between exploration and exploitation. So if you're exploring, you are foregoing the opportunity of using your money to exploit the known things. So that's the trade-off between exploration and exploitation. So you have to know about the nature, you know that dynamically, so you learn about the arm, and when you are learning, you're foregoing certain opportunity. So this is the model which we use. I'm relegating the literature survey until the end and going to the model. So it is a continuous time model, and every firm, there is a common discount rate of R. It's a continuous time discount rate. That is how you value the future in today's term. There are two firms. Each of the firms at a time point, they allocate certain amount xi to R&D. That means they have 1 unit of divisible resources. Out of that, each of the firms simultaneously choose how much resource to allocate to R&D. There is a flow cost of R&D, C. Now comes the fact that this research avenue, this R&D avenue which the firm is putting the research intensity, they do not know the quality of the research avenue, in the sense that a priori they only know that it can either be good or it can be bad. The firm starts with a common prior, meaning that both have a known likelihood of the arm to be good or the research avenue to be good. Now, a good avenue generates innovation with probability xi dt time. That means if a firm is putting resource xi for dt interval of time, then the probability that the innovation will arrive is xi dt if the avenue is good. However, if the avenue is bad, no innovation ever arrives. Bad avenue, right. Now, how do the beliefs update? How do you learn about the feasibility of the research avenue? Suppose you are putting resources and over time you are not getting any output, any innovation, meaning you are slowly getting more pessimistic about the research avenue being good. Hence, the belief starts falling, and that is proportional to the amount of resources you are putting in. However, moment the innovation arrives, the belief jumps to 1. That is, it's a good news model in the terms of bandit model. That is, moment you see one innovation, you know for sure that it is good. So the belief jumps to 1. Now, if there are 2 individuals or 2 firms, then the learning rate is higher, because here we assume that both R&D efforts are publicly observable. Okay, R&D efforts are publicly observable. Firm 1 and 2 both putting resources, both seeing no public arrival of innovation. They know that higher amount of resources were put, and that's why you can see that it is the red line through which the belief is going down, compared to if there would be only one firm and putting some resources, it would be the blue line along which the belief is going down. I will go back a slide to say about the implication about the learning here. As I said, that moment an innovation arrives, the belief jumps to 1, right? And I have also mentioned that if you have to learn about the feasibility or the viability of the research avenue, you need to put resources. Now, suppose I am firm 1, there is firm 2. I see firm 2 is putting resources. I know that in the event there is an innovation arriving, that is also giving me a benefit in the sense that I would know for sure that the research avenue is good, and then I can take the benefit out of it for my subsequent innovations. So this tells me that I will have some kind of free riding problem. So that is the thing which happens in the competing firms case, that one can actually take the benefit of other players' learning, which the merged entity will internalize it, and that is what we call the informational effect. Okay? So we assume that there are 2 innovations, as I said. The first innovation is the game-changing innovation, and the second innovation is the follow-up innovation. What are the payoffs? If there is only one innovation taking place, the firm who got the innovation gets a payoff of pi. When the second innovation arrives, then the first innovator gets lambda pi, and the second innovator gets phi pi, such that both lambda and phi are less than 1, but lambda is higher than phi. So meaning, moment there is a second innovation, there is a competition, and that is taking away some of the benefits of my innovation. So that's why the payoff goes down from pi to lambda pi. There is a loss of it. However, since I am the first innovator, I have some first mover advantage. So I start at the game-changing innovation, which is better. So I always get more than the subsequent second one. Now, here we assume that it is possible that only one firm gets both the innovations, in which case the payoff is lambda plus phi to the firm who gets both the innovation. Now, our goal is to compare R&D by competing firms to the R&D by merged entity, and to make this comparison meaningful, we assume that the merged entities research, maximum intensity of research is 2 units. As I have said that in the benchmark model, there is no synergy or no price effect, in the sense that I just mentioned that if I am the firm who is making both the innovations, I am getting the payoff lambda plus phi times pi. It is same as if I am inventing the first innovation and there is another follow-up, he is getting phi, I am getting lambda. Ideally, one would see that if I have both the innovations at my disposal, I would have a monopoly in the end market, which would give me higher payoff. In the benchmark model, we do not do that. However, we show that even if we include the price effect later on, the results are robust. Qualitatively, the results do not change. We will show in the end. So now I will discuss the result with the help of some pictures. So this is a picture. On the horizontal axis, I have lambda, the payoff the leader gets, the first innovator gets in the presence of the second innovation arrives. And the vertical axis is phi, the payoff parameter which the follower gets. At this junction, let me say that this phi lambda, they might seem exogenous. However, in the paper, we have detailed micro foundations for these parameters. We show that these are actually consistent with the differentiated Bertrand model, which is there in the paper. Now, since we said that the first innovator has a first mover advantage, then lambda is always greater than phi. So the shaded part of the triangle is the relevant area we have to focus on. Okay? First area is that when the merger has no effect. What is the intuition? Intuition is that costs are such and the parameters lambda or phi are such that neither in the merged entity case or in the competing firm's case, second innovation is never profitable. Which means all this issue of information, appropriability, they don't arise. So merger and competing firms, they give you the same result. Next, we have an ambiguous effect place. It's such that phi is high enough so that the second innovator finds it beneficial to bring the second innovation in the competing firm's case. However, lambda is not high enough to ensure that the merged entity finds it beneficial to do the second innovation. Why? Because the merged entity not only takes into account of the additional payment from the second innovation, but also he is concerned about the loss in his payoff from the first innovation due to the second innovation. That's the cannibalization effect. So due to the cannibalization effect, the merged entity in the yellow region always blocks the second innovation. However, because of the appropriability effect, what is the appropriability effect? The merged entity knows that the second innovation will be blocked, hence the profit from the first innovation is higher. This gives him incentive to do more R&D for the game-changing innovation. And not only that, competing firms always go for the second innovation. That means a competing firm can have the free riding effect from his rival. So when it is competing firms, each can free ride on their other's effort in the game-changing innovation, which reduce their R&D effort, which is internalized in the merged entity case. That's why we say it speeds up the first innovation because of the informational effect and also the probability of the first innovation because of the appropriability effect. I will explain this with the respect of the probabilities when I discuss one of the policy implication. And the cannibalization effect blocks second innovation. So this is an ambiguous region. Right. Finally, we have the region where merger is always beneficial in the sense that in this case, whether it is merged entity or competing firms, second innovation always takes place. So no cannibalization effect. However, the informational effect is still there because the free riding is still there and appropriability effect is also there because now the merged entity knows that if there is a second innovation, it is him, he is going to reap the benefit of the second innovation. So there is more appropriability effect which increases the probability of the game-changing innovation. So this is the picture we have. Now coming about policy implications, I will talk about two things. What is the impact of the prior, technical term, meaning how is this merger, how is this R&D research effort depending on the likelihood of the feasibility of the game-changing innovation? And finally, what is the role of innovation substitutability? So in order to do that, first let me discuss what is the mathematical implications of the appropriability effect and the information effect. Now suppose we start with a common prior P naught, which is the likelihood of the research avenue being good. Now as there is no innovation arriving, belief would start drifting downwards. We would start becoming pessimistic about the feasibility of the game-changing innovation or the research avenue. Now from P upper bar onwards, the competing firms know that they can free ride on each other, hence their research efforts keeps decreasing from P upper bar to P lower bar. However, the merged entity internalizes that, hence put higher effort. So this is the region P lower bar to P upper bar we call the informational effect, where in case of merged entity, research intensity is higher, but in case of competing firms, research intensity is lower. And finally, the competing firm stops entirely their research intensity at P lower bar. So this P hat, this green shaded region is the appropriability effect. That means that is the additional range of beliefs where a merged entity would carry out research, but the competing firms will not. Now, how is this related to what we say about the prior? Look, the benefit of the merger only arises if we are in the region P upper bar or below, correct? Now, if we start with a very high prior, P naught is very high, then the probability that the belief will actually reach P upper bar is lower, right? Because if you start with very high prior, there is a higher range of beliefs where in both case of competing firms and merged entity, they both put equal research intensity. So the probability that the belief would actually reach until P upper bar and below, that is lower. Hence, the benefit of the merger is much more pronounced if we start with a lower prior, when it is higher likelihood that you would reach that belief region of P upper bar and below. This gives us a theorem that the strength of both the appropriability and the informational effect decrease in the prior belief, and the merger is more desirable when there is more uncertainty about the feasibility of innovation. At this juncture, I will discuss two anecdotal evidences. First is 2005, when Google's acquisition of Android. At that point of time, future of smartphone remained uncertain. So feasibility, the prior was quite low, and hence the acquisition was not seen as anti-competitive that way. However, in recent times, if we talk about the Adobe Figma merger, which was eventually abandoned, there the market for productivity tools were already significantly developed, and innovations were more seen likely to be incremental. Hence, in such a context, merger raises greater concern because of the cannibalization effect we said. So our model can explain both these two anecdotal evidences. In one case, when the merger was not seen as anti-competitive, and in another case, when the merger was actually seen as anti-competitive. Coming to impact of innovation substitutability. Now, as I said, this lambda and phi, these are actually backed by proper micro-foundations model. And we show that how the path traverses in the diagram where we discuss the results of the merger. When both phi and lambda are 1, that means products are perfect, different products. There is no substitutability. There is no substitutability, independent products. However, as we go down, in the green region, merger is always beneficial. But when we just enter the yellow region, there is a drop in the benefit of merger, because at that point, merger starts blocking the second innovation. So there is a sudden drop. However, as we move down below the yellow region, what happens is that both lambda and phi are going down, which is affecting the probability of the first innovation by the competing firms. But the merged entity blocks the second innovation. So their incentive is independent of lambda and phi. So relative benefits of merger with respect to the game-changing innovation keeps increasing as we go down the yellow region. So this shows that if we just, it's a numerical example, that if we have the substitutability thing on the horizontal axis, on the left it's the green region, on the boundary of the green and yellow, when the merger just starts blocking the second innovation, there is a drop for the welfare of the merged entity. But as we still keep going down the yellow region, that means as products become more substitutes, then merger becomes better. So this says that the blocking of merger and substitutability of innovations, it can be non-monotonic in the sense that when either there is no substitutability, products are almost independent, merger might be better, or when they are very much substitutes, close substitutes, merger might be better. In the intermediate region, when there are moderately substitutes, it might be beneficial to block the merger. Finally, couple of minutes to introduce the price effects. Price effect means that if one entity or the merged entity or both the firms coming together, if one firm owns both the innovations, then their payoff is big gamma, which can be greater than lambda plus phi. This means greater market power. We know that this firm will have a greater market power in the end innovation market, and traditionally we would expect that harms the consumer. Okay? So that's the channel of harming the consumer. However, we show that qualitative results remain unchanged. Why? Because of higher market power, monopolists now mitigates the cannibalization effect. They know that if they own both the innovations, in the second stage, they know that if they can grab the second innovation as well, the cannibalization effect will be much lower, coming from the fact that gamma is greater than lambda plus phi. Again, we have micro foundations to show how gamma is greater than lambda plus phi. So to give you a numerical example, the solid lines are drawn for low prior thing, means highly uncertain game-changing innovation. There we show that a merger can always be beneficial with respect to competing firms. However, as I said, that if it is not that much uncertain, if it is more certain, in certain regions, merger can actually be falling behind. And the reason behind this is that in this case, there is this price effect as well. But the solid line shows that even with the price effect, the qualitative results remain unchanged. So to summarize, the merger affects different types of innovations differently. It can increase the probability of the game-changing innovation. It can decrease the probability of the subsequent innovations to avoid cannibalization. Novel informational effect, it may bring the game-changer innovation forward in time because of the free riding problem we just explained. And the merger is more desirable when there is more uncertainty about the feasibility of innovation. And contrary to the traditional merger analysis, merger can be more desirable if innovations are closer substitutes. So this is all I had to say, and these are the literature where we have based our study. And so it goes to both the merger and innovation literature and also the strategic bandit literature where we take the structure from there. So I think this is all I had to say. Thank you.
Thank you. There's a lot to take in there. Questions?
Thanks, Kaustav. What you are saying, game-changing, is essentially disruptive innovation.
Sorry.
What you are saying, game-changing, is essentially disruptive innovation. That's the people call it.
Not disruptive. I mean, it's something which is very new. I will not call it disruptive, but it's life-changing innovation, maybe.
Yeah, that's called disruptive. And the other one you are saying is called marginal. So I'm talking about the...
Relatively less important than the first one, yes.
Okay, so disruptive innovation is something that is completely new, that changes the research path.
Yes.
That's what disruptive.
If you call it, yeah, that's fine.
No, that's the
sure.
The literature. So, and if you look at the 23 Parquet or Nature paper, it says that essentially disruptive innovation is declining over last 3 decades.
Yeah.
Okay, and marginal is going up. So your stylized model, does it say that one way to get reverse the path is to allow merger?
Maybe yes. Maybe yes. Offhand, yes. In the sense, of course, there cannot be a simplest answer there. But yes, the current thing is that. So I have some follow-up papers on multi-arm bandit where we show that yes, sometimes in pharmaceutical industries also that innovations, number of new products are going down, And that's because there are too many duplicative efforts. That means there are competing firms in that stage. And what you're saying is consistent with the situation that when there are competing firms, the game-changing innovation is not coming up, but subsequent innovations are coming more because mergers are blocked and their cannibalization effect is taken care of. Yes.
And another related to that, so there also are cases of parallel teams within a firm
Yes.
who are trying to do the same innovation.
Yeah.
And one of the biggest problem is replicating the same thing.
Exactly. So that is something can be addressed by this multi-arm bandit structure very well, in the sense that if you are to talk of teams, so there are papers called strategic learning in teams. I mean, my co-author with whom, Nicola Klein, with whom I have had bandit papers, he has a paper on strategic learning in teams, as you were saying, that if there are teams and if we have this experimentation models, so bandit models, it is possible that you are duplicating efforts. You're actually duplicating effects. When you should be specializing, you are duplicating effect on a different context. And that's because of the free riding thing always.
Essentially, your paper is saying not to have parallel if you want to.
Yes, sometimes in certain context. But of course, I mean, I have to reframe. I mean, it's a stylized model, true. Yeah. But then it's giving us some idea about what is happening. Yes.
Thanks.
Helen? Oh. Maybe have two questions, Helen and Franco.
Hi, just wondered, what's the social optimum? Do you solve for it?
Okay, social optimum, sorry, maybe I should have...
Duopoly, but what's the social optimum? I think implicitly in papers like this...
Yeah, the social optimum is basically the expected consumer surplus, discounted consumer surplus.
But which of these outcomes is closer? I mean, it's not always the case that more innovation or early innovation is the social optimum.
No, so it is like, so we say that, so second innovation is conditional on the first innovation arriving, right? So we can actually, as I said, that these parameters we have, they're derived from a micro model, which gives us the ability to calculate the expected utility of the consumers.
Yeah.
Conditional on one innovation, conditional on both innovations, and conditional on no innovations. So we actually calculate all the expected discounted utilities, and all the things what the numerical examples I have shown, they are actually having basically the consumer's utilities, consumer surplus actually.
Yeah, thank you so much. So one question that it's on top of my mind, is particularly pharmaceutical, is this disruptive innovation versus if you want, the incremental innovation that you have it there. The incremental one is if the two firms were competing, the firm that lost on producing if you want, the disruptive innovation, what is really the chance that that firm will compete again for the incremental innovation? If you look at the patent, typically it's a different game. The one that described the feature is the fact, you're the dominant firm, what you want to extend your patent. So the incremental innovation is your strategy to avoid different type of competition. So it's not that we're talking about this model here. Yes. But in principle, this is a model that can explain killer acquisition. It's a model that can explain important feature of competitions, But coming back to the question, I think part of the reality is not captured by this model. Yeah.
Yes, thank you so much. So here we have said that both the innovations come from the same research avenue, right? So once you know that the research avenue is good, true. We actually have a follow-up paper which is also there. I mean, the preliminary draft is actually in Arina's web page, you can see. In the follow-up paper, there can be two avenues to innovate, and we actually take it to an independent quality of the arms. So that is, in technical terms, that is independent arms banded model, but that is there as well. So as you just said, that we have that thing going on, and there are certain additional insights we can get from that model, but that is becoming a more technical paper. I mean, that is there, but if it's a pertinent question, and we are addressing that in a follow-up paper. So we have a preliminary draft, not circulated, but you can actually find it in Arina's web page.
Very briefly, I have a question and also a statement. Statement is, I don't know if Google Android is the best example of the difference between that and Adobe Sigma. It was a very different time. I think lots of people think that was a bad merger decision. It was also a merger decision where they were very different products and where the issues were really quite complicated around bundling different systems together. And so I'm not sure your model really fully captures the Google Android case. But that's not an issue. It's just, I don't, yeah. But the other question I had was, most authorities will typically only find a problem where the products are substitutes rather than fully independent. Your upper part, where you've got phi high and lambda high, is where you have independent products, which is typically where a merger would let the merger through anyway, which fits with your findings. But where they're, I think, roughly your line of yes, the line between the yellow and the green seems to me to fit quite nicely with the difference between, somewhere around there, the difference between substitutes and independent products. And therefore, are you kind of saying that merger authorities are doing it about right, in that they're blocking mergers where these things are substitutes?
Yes, that's what we were saying, that here, when we are in the yellow region, which is closer to the green region, our model says that it is indeed beneficial to block merger on that region. However, if we are in the deep down the yellow region, then merger might be beneficial. So we are saying that there is no uniform policy prescription on the yellow region. Our take on from the model, of course, our model says this, that yes, it is right that when we are in the yellow region but closer to the green region, then merger should be blocked, because for the obvious reason that in the boundary there is a drop and then it starts. So that's what this example states us, basically, that you are doing the right thing when theta is in the moderate region, but if theta is too high or theta is too low, merger probably might be beneficial. That is what we are trying to say.
Okay, very interesting. All right, I'm afraid we should get on, but Tanya, if you want to speak in the break, then that would be brilliant. In the meantime, Farasat, ex of the UEA and CCP, well, he's still part of CCP, really, but he's ex of UEA. He's now a professor at Loughborough. He was incredibly involved in yesterday's sessions. So you saw him yesterday, but he's also very expert in everything that was discussed yesterday, but also very expert in what he's going to discuss now. Thank you
very much. So let me get started. So this paper is about using online methods or experimental methods to do some merger review. It's co-authored with my student, Jan Serevardana, and my colleague, Stefan Pezensky. This paper that I'm about to present is actually from Jan's dissertation. Unfortunately, last month he passed away. So this is a little bit in his honor. I'm going to take a moment of silence. Okay, let me get started. So, in recent years, between 1/2 to 2/3 of the EC's merger cases have used either upward pricing pressures or diversion ratios. And sometimes to get these things estimates done, you may want to estimate demand functions, or you may want to do some other methods to get a sense of these diversion ratios. But estimating demand functions is a very rigorous and challenging exercise. But it does form the foundations of merger assessment in some sense. Regulators face obviously time constraints, and doing these type of exercises can be very, very difficult in real time. One can at best hope to do some diversion ratios type of calculations based on some qualitative data or even quantitative data if they can quickly get those, but getting in full-blown estimates on demand estimation, things like that can be very difficult. So CMA has 40 working days to complete phase 1, which is clearly not enough for these type of exercises. Even if you went into phase 2, it still wouldn't be enough time, because if you've done these type of calculations, you know that it can take a long time. So the main model that is often used, at least in the academic papers, is the workhorse is the random coefficients logit model coming from BLP's or Barry Levinson-Pecos' original work, but then follow up from there. So that's often taken as the workhorse. And It's really difficult to estimate such a model. Even if you are to estimate this model, it makes a lot of assumptions about what the world will look like under uncertain conditions. And you want to do it, you may not have data in the right time to do it. Sometimes you can perhaps get the data through discovery or something like that. But in general, even if all these conditions are there, plenty of people in this room have estimated these type of models to know that this is really difficult model to estimate. To get the estimates right, it takes months to check all the assumptions, to get the instruments working right, to do all sorts of things. So with these type of time constraints there, these factors limit the ability of certainly competition authorities, but perhaps others as well, consulting agencies as well, to use these in a direct way. This is a quote from Tommaso Velati, which I heard him say in one of the conferences as well, but it's also published somewhere, that in his 3 years as chief economist at the EC, he never encountered a random coefficient BLP style model being used in any of the mergers. And to me, it feels like, well, this technology so far, we know came out in mid-90s. That's when we started becoming aware of it. Over time, we learned a little bit more from it. Never wrote some papers about it on how to start using it, the practitioner's guide and so on. But even in 2025, if we're still only once in a while using it, it seems like this is a technology that exists, perhaps. This is something that should be brought forward into practical cases as well, not to replace anything that the competition authorities do, but as an additional tool in their toolbox to help inform other things that are going on. So in this paper, we basically asked the questions that can experiments be used to estimate demand parameters and then contribute to merger assessment and other policy evaluations. So we're doing it in this particular proof of concept style paper in the context of a merger analysis, but it need not be limited to that. You can do these type of things in other policy evaluations as well. You wanted to do it to understand how the counterfactual will work. Let's say if you put some tax and this endogenous selection of product characteristics, you need to know to figure out the equilibrium for that, what the parameters of the model were, right? So the key question that we're asking is, can we do this in a way where we can get the key parameters out of the lab experiment? So we're going to run an online experiment using hypothetical choices to obtain parameters of the demand. Then what we're going to do is we're going to take those parameters and mix them with real-world aggregate data. And in our case, we're going to take very cheap data. We went to the internet, got data on beers, shares of beers from the US, aggregated at one national market level. What's the shares, what's the prices, and what are their characteristics? To sort of show that you can actually do this even with very little data. So it will be for one market rather than disaggregated markets the way we might want to do it city by city or period by period. But as an example to show, we want to do it from here. So using these demand estimated parameters, demand parameters, and the aggregate data that we're going to do, we're going to put those together and say, look, in a merger simulation, you have actual data. You've spent months trying to figure out the parameters, but what do you do as the next step? You somehow try and back out the marginal costs from those things. We're going to do the same thing. We've just done the parameters in the lab. We've got the aggregate data. Let's put these two together, somehow line them up in a way that they make sense, that these parameters line up with the real-world data, and then let's back out the marginal costs. And then we're going to run a simulation. Our claim is that you can get the data in 3 days, you can run this entire exercise in 4 days, and you can be done with it in 1 week. It can be an input into larger assessment. Okay? That's the key. Not only that, the additional claim is, because we're going to use lab methods, you're going to be able to estimate the parameters using canned routines if you want. You can take the data, send it straight off to Stata, press the button called regress on your computer, and you'll get the parameters. You don't have to do all the BLP-style advanced estimation yourself. Now, if you know it, it helps, obviously, but point is that you can do all of this thing fairly fast. So we're going to estimate mixed logit parameters from the lab. We get some data from the real market. We'll look at the existing ownership structure between those products. And then we're going to change the ownership structure and let a new equilibrium evolve in terms of prices. And then we're going to do all the welfare calculations and all the usual stuff. Okay? So our idea is that we're going to do the stated preference method. We're going to show our recruiters, people that we've recruited, some hypothetical choices. This type of method is obviously used in other branches of economics and social sciences in general. This is nothing new. So we are just using that. Data can be quickly collected. That's a pro from it. It can be designed to contain such variation in each attribute as is appropriate. So you can randomize things. You can even randomize the price, which is what we're going to do. So you get rid of a lot of endogeneity problems that usually you have to face with in the real world data. And then we'll show that the ability to target specific demographics over here. In our case, the demographics that we chose were not the best ones, but that's not the point of this particular paper. In general, you can target specific demographics. This experiment, when we ran it, it was done online during the times of COVID. We paid the participants $2 to participate, and we had several thousand, and I don't remember how many people we had. It's written somewhere in the paper. But the whole thing was done in under 2,000 pounds. So it's a low-cost, fast-acting application. It also has its limitations. The biggest limitations you'll see is that incentivization is very difficult. In fact, in some cases, almost impossible. And you cannot model the outside option very well. If you have real choices, people have to put their money to buy beer or their money to buy a house or whatever, they can walk away from it, right? So we have to somehow do it that even though we cannot give them that money to incentivize them to make the right decision, nor can we give them the outside option, how can we solicit information from them in a way that's still useful? Yeah. So we're going to do it in the context of beer, and then we're going to provide some external validity, or try to provide some external validity over here. So we define a set of attributes for each product type, define number and values of each of those attributes. So, if it's beer, whether it's in a can or bottle, what's the different prices, what are the different tastes available. And then we define number of choice sets and options in each choice set. There's combinations of products to the subjects that they will see. And then we have overall 2 treatments over here. The 2 treatments are, in the first treatment, it's choice set 1, which we call intra-brand choices. So here we're going to give the choice to the individuals in such a way that they're not choosing across different brands. They're not choosing between Miller Lite versus Bud versus something else. They're choosing within a brand different types of beer that might be available. And we motivate it that way, that the company is trying to launch a new product, which of these would you choose? And the second one is where they have to choose, which is we call inter-brand choices, where we basically have to show them which brand they're going for and let them do it. Now, take a mental note of these 2 things. If you're in the gambling business, place a bet, which of these 2 is going to work better, and keep a note of that. And you might be surprised in the end. Okay, so here's the basic choice set that we're going to show to the participants. We're going to set 3 different levels of prices, written as above, 3 different values of ABV, 2 choices of the type of container, and then the size of the bottle that they're purchasing or the size of the can that they're purchasing, small, medium, large. And we got these parameters by just Googling around, looking at what are the typical values of these type of beers, what are the typical values of choice of cans and sizes, and we just made up some numbers around those things that are close enough to this thing. So given these choice sets that we're giving, we have essentially 18 pseudo products to choose from, if you multiply these out, but that's without the prices. If you put it with 3 types of prices, the choices become 54. Okay? So then we showed the participants. Each participant, we show them 8 choice sets for each product type with 4 alternatives at a time. So they have to pick one of the 4 choices. And the participant is asked to make the choice 8 times. Okay? So there's a cross-sectional variation, and for a given participant, variation over the 8 choices that they make. 4 random alternatives were drawn from the set of 54 without replacement to construct the choice set. The rest is we did it online. We have a little bit of a skewed sample of the type of people we got. We picked college students of a particular age, but that's not going to be the main point over here. Okay? And the cost was very, very low over here. We also did some tests on it to see whether they're doing straight lining or gave choices that were dominant than the other one to see if they're consistently picking just, without doing anything, clicking on things. There were no such big problems over there. Yeah. Some data we had to sort. So in the intra-brand, this is a typical screen that you will see. There will be a randomly chosen logo on the left top. Here it's Stella. Then there's a question being posed that Stella is launching a new beer. These are the 4 choices that they're considering. Which of these would you choose? Okay? So they are not thinking of Stella versus Miller versus Budweiser. It's like, okay, this is it. It's Stella. Which of these do you want? So they pick one of these. And then they're shown 8 such choices. This essentially is the entire data set from this experiment, from the intra-brand one. Here we are listing the 18 choices that they're getting. We're listing the characteristics of those 18 choices in the first 3 columns after the product number. Then we say how many times this choice appeared in the choice set. So for instance, with a price of $6.49, the product number 1 showed up 308 times. With the price of $7.99, it showed up 274 times, and so on. And then in the last 3 columns, it shows how many times that product was actually picked. So with the price of $6.49, it was picked 47 times. With the price of $7.99, it was picked 23 times. With the price of $10.99, it was picked 11 times. Use your imagination, squint hard, look at rows. What you'll see is left to right downward sloping demand curves. As the price is increasing, fewer people are choosing this. This is telling you roughly that people are paying attention to the price. They are not just engaging in cheap talk, because if they were engaging in pure cheap talk or just clicking, you wouldn't be seeing this type of a pattern emerge out of it. Okay? This is nothing much to pay attention to other than we're pointing out that there are 2 dimensions. There's cross-sectional and selection for a person over time. And it's basically pointing out that most of our variation is coming from the choices that a person is making over time, over the 8 choices, because the price ranges are restricted, so are the characteristics. So that comes from looking at the standard deviation in the within versus between rows. And essentially, the main message is that what you're going to find is that the standard deviation in the within rows is typically larger than the standard deviation in the between rows. That's all it means. Okay. When we are doing BLP style estimation, I'm not going to show you equations upon equations, just one point to make. When we're doing BLP style estimation, a starting point is often to write out a utility function of some sort, which is a function of the price, product characteristics, and an error term that has a specific distributional form for it. And the key is that when we're doing random coefficients, we let the coefficient, in this case, for instance, alpha, vary for each individual, that it has a distribution and each person gets a draw from it. So we call it alpha sub n. Okay? Whereas if you're doing straight up logit or something like that, that alpha n just becomes alpha. Okay? So the key is that we're interested in estimating the mean and distribution of this alpha. And with this data, you can take this data, put it in Stata, press the button for mixed logit, and it will give you the value of alpha's mean and its distribution. Okay? Same thing goes with whatever the betas are, which are the coefficients. So if you do that, there's your parameters. All the parameters that we needed are out there. We have the mean value for the parameter alpha and its standard deviation, the standard deviation of that distribution, and so on for the other coefficients that we have in here. This type of exercise usually takes a long time to get it right when you're working with the real data and when you have to worry about instruments and things like that, and you're working with aggregate level data. When you're working with individual level data, this can be handled with canned routines, is my point. Okay? So we got these parameters. Okay. Now, how do we tag them to the actual observed data? So we get the parameters, and our idea is very simple. We say, let's get predicted shares from this lab data, and let's look at the observed shares from some market and try and match them. So this is basically what we're going to do is we're going to look at those two shares, and the difference that's going to be left over is what is usually caught in the BLP type of model as the error term, which is the unobserved quality of a product. And there's a fixed point method to get that value within it. So we calculate the mean utility, we let it iterate, and we get essentially the shares to match up. And what's left over, that gives us the error term that's left over by construction. When we have that error term, we can now construct the elasticity matrices. Elasticities on and cross elasticities, and from that we can get divergent ratios as well. This formula I've written over here is just the elasticity formula that comes out of this type of a demand model. Okay? But the key that we're doing over here, and why I've color-coded it, is the following. We have the demand parameters. We've got the shares. We're going to take the logit model, and we're going to insert in it not the values of the x's or the product characteristics and the prices, but we're now going to insert in it the real observed product characteristics and the real observed prices. And with the real observed product characteristics and the prices that we have, and our model estimated parameters in the lab, we're going to put those two things together to get share, which is S, predicted shares that we're getting here. With these predicted shares from the model and observed prices from the real world, we put them in this formula and compute the elasticity matrix. That's the ATER JK. That's the cross elasticity between product G and product K. So this is absolute standard elasticity formula with just the difference is that the S in here, which is the share, is the model predicted share, which has been tagged, linked to the observed shares by changing the error term, and then the observed characteristics of the products actually out there. And when we do that, this is the elasticity matrix that we get for the top 18 brands that we looked at in 2000, whatever year we were doing this thing. At that point, what were the shares? And I think we got these values initially from Statistica or something like that. We filled them in here, and we color-coded the ownership matrices. So the first 7 that you see that are in one color are owned by one firm. The next lot going from 8 to 13 is the second firm that owns these brands, and so on. Okay? So along the leading diagonal, you have the own elasticity. On the off diagonals, you have the cross-price elasticities. Okay? So we get this thing, and we say, okay, now what? Well, let's first compare what we get with a very famous paper that had used Beer's data, Miller and Weinberg. A lot of people reference this paper. And what are their estimates? This is not to say that we got it exactly on the nose, but this is to say we're not getting crazy estimates here. We're getting something roughly in the same ballpark where very experienced researchers spent a lot of time with real data and got these estimates, and ours are not too different from that, okay? Except we got it in a cheap amount of time and low cost. Okay. Then we went on to the next one. We say, okay, what's the median own price elasticity? We got it as minus 6.5. And Miller and Weinberg have given a range in their paper, which is from 4.73 to 4.33. Then we compare our price cost margins, which we are getting 20.22. They had 34. So there we are not exactly on the nose. But remember, when they did their paper, it was much earlier, different period of time. Since then, there were more mergers that have happened. And we're using almost 7, 8 to 10 years later, the shares that were out there of these products. Okay. So next thing was, okay, let's do all the usual exercise that merger simulations do, which is let's assume some sort of a equilibrium model. You use the equilibrium model as typically a Nash-Bertrand model, and you put in there and back out the marginal cost, and then you change the ownership matrix, and then you predict the new prices. All that machinery is there. So we do that, and we say, let's merge two firms that were the first two biggest firms, and what are the predicted price changes that we're getting? And that's listed in the last column over here, the predicted price changes and the predicted shares that we're getting. So I'm not going to talk about treatment 2 in detail. What I'm going to show you is this is how treatment 2 was set up. People see the choice as across brands. You can see that the brand becomes very salient now. It's very obvious what you're choosing in. And when we do the same exercise of squinting your eyes and looking for left to right downward sloping demand curves over here, you will find none. What's happening with this setup is people are now engaging in cheap talk. They're looking at these pictures so intently that they have no outside incentivization going on. All they're doing is clicking on their favorite picture. They're telling us what beer they like. And so when we do the estimates using this other one, we get very, very inelastic demand. Very elastic demand. People just don't care about the price coefficient anymore. And when we essentially do the same elasticity type of calculations, we get in a very different range, very far away from Miller and Weinberg. So this picture captures it, different types of estimates that we get. On the top right corner, we have Hausman's estimates from 1994 paper using a very different demand model. He used AIDS-style demand model. We have Miller and Weinberg from 2017 in the top right corner. And you'll see a blue dot in there, which is our estimate using treatment 1, the initial treatment. Down here are two other estimates from a 2004 and a 2008 paper in the middle. And then bottom left, which is out here, is our own estimate from the second treatment. So what this is showing is that there are two different ways of doing it. You have to be careful. The second treatment, ex ante, we thought was going to be better because we were showing the brands and we thought we can capture a lot more reality that way. What that ended up doing was generating a lot of cheap talk. People stopped paying attention. So if you want to get the estimates right on the price coefficient, you actually don't want them to choose between brands because you're not giving them money to walk away with. Had you given them money to actually make the choice themselves, then they would have to think about it, which one do I really care about? Otherwise, they're just telling you what's their favorite beer, essentially. And that's it. That's the summary.
So I think this is an incredibly intriguing approach. Questions? Maybe the one at the front first.
Thank you, Farasat, for taking on historically important precedents set by Miller and Weinberg and the others. I appreciate that you've done experimental economics essentially, and have you, how have you picked your participants? Do they even like beer? And with regard to your comment on, that they may not be engaging in cheap talk because you've seen a certain trend, it also depends, how they respond depends on what they know about what you're looking into. For example, the Hawthorne effect can kick in. And if you're trying to say if they're marketing, students of marketing, they will respond in a particular way because they want you to believe that they are actually market savvy. So please, can you comment on that?
So I think in general, experimentation with students has been validated in a lot of other experiments. People have done these type of things where they put students in labs and get them to run experiments. And that's something I didn't look into it because the literature believes in it, that things work out quite well. Experimental economists have done a lot of work. I'm not an experimental economist by training or anything, but I believe that it does work. As for these specific students, whether they were drinking students or not, yes, that was one of the criteria that we had for enrolling them. When we advertised, we were advertising to college students of drinking age within a certain demographic. It was done online. We were paying them very little money because we didn't have that much money to run this experiment. So these were college students of drinking age. And we did ask them question, do you drink or not, before selecting them. If they could have answered untruthfully, that we don't know, obviously.
In the UK, they could have been 18 and up, but in the US, 21 and up.
Yeah.
And there was another question at the back, which was...
Yeah, sorry. My question isn't on econometrics or demand estimation or industrial organization, but us experimentalists don't really consider an online experiment a lab experiment unless you ran the online experiment in a physical lab. But wait, it's not a criticism. I'm not criticizing your design or choice, but my question is, there have been a lot of field experiments going into top journals like AER. So since you're collecting your data from experimental participants, if you were to do this in the lab, or lab in field or field experiment, do you think you see differences in the data? Because this will have implications to your estimation. Not too sure if this is relevant, but yeah.
To be honest, I do not know. I mean, we have not experimented that if we did it in the field versus in the lab versus online experiment, the way we did it, how much difference it would make. But again, I think on those things, there is some literature out there that can talk to better on that point. Our view was just, look, we are doing it under COVID times. Labs are shut down. We can't put people in the lab. Even if we were to do it in a lab, we simply cannot incentivize them. And even if we were to incentivize them, what would it achieve? Because in some real world case, what if the method that we're proposing is applying to a choice of buying cars? There, you're not going to give them enough money to go and start buying a car or walking away with that money. So our idea was, let's do it in a case where incentivization is not we don't do the incentivization and see how it works. And we tried one way, that we did it online. It seems to be giving reasonable estimates. Would another method give it easily similar estimates? Yes, but you may not be able to get this many people in a lab that fast. It might become that you have to then drag it out for 2 months or 3 months because labs are limited in size. But when you're doing it online, 1,000 people can log on. Within 2 days, you'll get your results.
Yeah, I forgot to say, if I had unlimited constraints, money, and resources, you
Yeah.
could do a lab.
Just on this point, I mean, actually, some people have done work on the relative results of those different types of approaches to experiments. And in fact, Zita Vassas, who did her PhD at UEA as well, looked at interventions to encourage search and switching in financial services markets, and then looked at lab experiments and also field experiments. In that particular environment, she found that the field experiments figures were much lower than the lab experiments. And the reason was that obviously in a lab, people were kind of focused and thinking about whether they would switch, and then in reality, they don't. However, I think that is a very different context to this. So I think it probably depends on the context, the answer to your question. We've got 1 more minute if anyone's got a question.
Yes, over there.
Oh, yes, please.
Wasn't clear to me what's the advantage of the experiments. I mean, in the end, you do the entire estimation anyway. You just do it with market shares that are coming from the experiment rather than the real market shares.
No.
But if you had Nielsen report, you would have the market share. So I'm not sure what.
So what we are doing is that if you had done it with the real data, you would have to spend months trying to do from the aggregate level data and use the full BLP model, and you'd have to worry about getting instruments for prices and all that stuff. When we're randomizing these things and we're looking at individual level responses as opposed to aggregate, the estimation procedure is very different from doing it, and you have canned routines for it. So you can get the parameters of the demand or of the utility function from the lab experiment. Then what we're doing is we're matching the share that we get in the lab with the share that we observe from one market. We took the national market, but you can do it city by city if you like, and try to match those so that when we do the predicted shares later on in elasticity, those match up and we are on the nose that way. So the advantage is you're shaving yourself a year. Instead of spending a year trying to do these things, you're doing it in 3 days. And you're doing it at a cost of $1,000.
But if you had consumer level data from Nielsen,
then you could do it, but even there you would still have to worry about endogeneity. You would need to find instruments and all that stuff. Here we are randomizing it, right, in the lab.
So
we're
we're
generating all the prices ourselves.
Partly we're creating competition to Nielsen, who charge a lot for their data. We should, however, stop there. I have no idea if I'm meant to be introducing this next session, but let's finish this session first. So thanks to everybody.